Today's project then is the assembly of this little foamy. I haven't attempted one of these before. In common with lots of things that I do, there are no instructions provided, so we're just going to have to make it up as we go along. What's that I hear you say? No change there. The little bag has the control horns and a laser cut motor mount. The other bits and pieces we'll just have to try and fit together. Takes me back to when I was a boy and little paper airplanes. We have some carbon reinforcing rods and the metal push rods there. See that they're pre-formed, which is great. Regular viewers will know that I'm quite keen on these very inexpensive kits that you can get. Contains a couple of propellers, the speed controller, 2 servos and a motor. The motor being this 2217 4-turn 2300 kV motor. Maybe a little over the top, we shall see. My receiver of choice once again is this Radiolink R8F 8-channel, and importantly for me, I love my telemetry, therefore we're going to be able to get the battery voltage back from the model, taking the guesswork out of that. All of that being said then, let's try and get some of these parts together. Unusually for me, I'm a fan of Yoo-hoo pour for foam, but there's so many joints here, I think the need for speed says that we're going to be using the hot glue gun. On the website where I bought this model, and as always links to everything down in the description, some wag said there are no instructions but it goes together the same as any other foamy model you've built. Well, I haven't built one, so that wasn't very helpful. I'm going to start off with the base. There's a little box section at the bottom here, and that's fairly easy to figure out. These sections with the notches in will just glue into there, and that gives us the basis to put the main wing and fuselage sides on. It's quite difficult just to push these on. What I decided to do was to bend them apart like that and then slide them onto the wing and then rotate them until these little tabs fit into the notches in the wing. That should go together quite well. I'm going to get the hot glue gun out now and we'll come back when I've done those tasks. Here you can see that I've attached the box section to the main wing. Importantly, before you put those two parts together, make sure that you glue in the carbon fibre support for the tailplane. And for that I use the Failsafe Sino and an accelerator. Once that's in place, just glue the two pieces together. The other carbon strip here I haven't glued in yet. I'm not sure whether I'm going to use the hot melt glue or maybe epoxy for that. We shall see. The other carbon strips that are supplied are to reinforce the vertical stabilizers. They will be glued on like so. Things then are coming together. I'll get on and glue those reinforcements in. Then we can turn our attention to the motor assembly. I elected in the end to use hot melt glue for the wing spar. If that doesn't hold, I can always peel that off and use epoxy instead. I've also gone ahead and glued the bottom piece in and glued the motor mount in place, this time using epoxy. I thought that that would be the best choice for the motor support. The next challenge then is fitting the top part and making part of that removable to be able to access the battery. This again is not obvious. There is a very faint line across here. Now whether this is by design or accident I know not, but it's just after the curved part of the canopy there. I think then if I cut across there, glue the front part in, then I can fabricate some way of holding this in place to be able to pop it out to change the battery. The only other thing to note is that the propeller with the supplied conical nut was too long to fit in there. What I've done then is to replace that with a simple nut, and that will fit in there like that. I'll go ahead now and make the cut here and glue the front part in. Then when I come back, we'll look at the installation of the electronics. I could find no indication of where to fit the servos. What I did then was to install the control rod first with the Z-bend in the elevator. The elevator and the ailerons clearly are linked together, it being an elevon control. Reinforced the hinges there with some Blenderm tape. That then set the position for the outside. I've used the longest arm that was in the bag for the servos. There's going to be much too much throw, but better perhaps too much than too little. The other reference point then was the motor mount. The back of the servo, or front depending on your point of view, is level with the back of the motor mount there. That gives you that position for the servo. As you can see, it's set up for the mid-range of 1500 microseconds with the arm as close to 90 degrees as we could get it. Now we can see that there's plenty of throw there, probably too much. We can obviously sort that out with our transmitter. That clearly then is the same on the outside, and I've just passed the wires through the motor mount there. Hooked up my speed controller and beck for the motor there. The next thing I'm going to do then is to put the propeller on and check the maximum current. The battery they recommend is anywhere from 1500 to 22, this being 1.8, kind of somewhere in the middle, and we'll come on to the vagaries of the C of G in a moment. And I'm just going to connect this up with the motor and my watt meter, and we'll see what sort of current draw we're going to get. Remembering that the propeller swings below the fuselage, make sure in this case I'm overhanging the edge of my bench, and I've already checked that the motor is rotating in the correct direction. This being a pusher, obviously the letters or numbers are on the front of the propeller. My servo tester set to the minimum. My watt meter here, as always, safety squints on. Certainly produced sufficient oomph, I think. What are we seeing here? 18.19 amps, 212 watts. That should be enough to get it moving along, I should think. What I've elected to do is to put the speed controller below this partition here, just with the motor wires popping out there, and this is my connection for the battery telemetry. This has two advantages. First advantage is that I can now move the battery around, or indeed change the type of battery quite easily. There's nothing in the way. And also importantly, now it has airflow over the speed controller through the hole here. There wouldn't be very much airflow coming through on the top there. To fit the top canopy, all that I've done is to stick a piece of credit card, and this is probably the best use of credit cards. That then forms a tab that you can slide under there. I've used some of the little pieces that are broken out for the tabs, just glued along inside there to support the top. That wedges it in there quite tightly. I don't think there's any need for anything else. If it does come loose, I can always put some Velcro on the back of the motor mount there, perhaps. The receiver comes with some double-sided foam attached. My idea then will be to glue that onto the top of the canopy there, and then I can plug everything in neatly with the wires out of the way. I'll get on and do those things now. Then I'm probably ready to set up the transmitter and check the control surface movements. I've connected up the receiver and bound it to my transmitter now. Let's check out the throws.
Welcome to OpenTX. Throttle disabled.
All sounds good. As predicted, a silly amount of movement on there. I do have set up some rates on there. Let's tone that down a bit. So to the right elevon's going up, left is going down, and vice versa. And elevator down is up and vice versa. That is all good. Without the propeller on, obviously. Check the throttle.
Throttle active. Throttle disabled.
So that is all good. I'll show you something now which isn't so clever, and another good reason for not having the prop on. If I switch the transmitter off, there is no failsafe set by default using the radio link receiver. You have to set that up yourself. It's quite easy to do. Main channels clearly are 1 through 8. Channels then 9 through 16 are the failsafe values for each of the channels in the event of a signal loss. In my case then, with the throttle on channel 1, I need to go in here and make sure that an appropriate value is set for channel 9 to make sure that doesn't happen. I'll go ahead and do those things now, then come back and look at any final jobs to do. There is some foam provided to create the nose, but I'm not very keen on this. I think for my particular landing style, something more bendy and absorbent is the order of the day. Therefore I've cut a plug and glued that in there. Now it's just a question of carving it to a rough shape. There. Functional, if not aesthetically pleasing. Final checks are now complete and we're ready for the off. You can see the battery location there. We've got plenty of space to go backwards and forwards. The top on there, a little bit of Velcro at the back. This is the mark for 50mm back from the firewall, and I think I'm even maybe a little further forward than that. She's pretty level at that position there. We are good to go. The last job was gluing the vertical stabilizers on. It's much easier to work on the model with those off. That's why they're the last thing to do. There we are then. We're waiting now for some decent flying weather. Hopefully in the next couple of days she'll be up in the air. Will she soar like an eagle, or will she plummet like a lame duck? We shall find out.